Hey everybody, welcome to the Soft Spoken Scientist. In this video, we're going to solve dilution problems step by step using the equation M₁V₁ equals M₂V₂, exactly the way these problems appear on Gen Chem exams. This equation only applies when a solution is diluted with water, the number of moles stays constant. So the V is the volume, all right? And the M is for the molarity. So let's get started. What is the final molarity when 50.0 milliliters of 2.00 M NaCl is diluted to 250 milliliters? So let's start with let's identify the values. We know M1, so we're looking for the final molarity, but we know M1 would be 2.00 M's. You got V1, which is 50.0 milliliters. You got V2, right, which is diluted 2, so it became 250 milliliters. And the final molarity, so it's going to be a 2, final 2, right? It's the end, it's not the first, it would be the second, which is the final, and M for molarity, equals unknown. I don't know what that is. Volumes can cancel, so milliliters are okay here. It's not like liters and milliliters, because that would have been a big different story. So let's plug it into the formula. We got M₁V₁ equals M₂V₂, right? So we got 2 times 50 equals X times 250. So I got 250X equals 100. I'm going to divide both sides by 250, and by doing that, I'm going to get 0.400 molarity, and that would be the answer. If you have any questions about that, because I know that's kind of new, let me know in the comments, but hopefully that did make sense. Let's move on to problem number 2. What volume of 6.00 molarity HCl is needed to prepare 500.0 milliliters of 1.20 molarity of HCl? Right, what you know and what you don't know. What volume of 6.00? Let's start with that. So we're starting with 6.00. That is my M1. Is needed to prepare 500 milliliters. So we all know milliliters is volume. And we know it's V2 because we're trying to become this. So 500 milliliters. And I say what volume? Well, then automatically I know I'm looking for the original volume. I don't know what that is. That's a question mark. And then I know my M2 would have been 1.20 molarity. So let's plug it into the formula. So we got M1 of 6 times V1, which is X. I don't know what that is. Equals, you could write V1 or X. It literally doesn't matter. Just don't put a question mark in the parenthesis. Okay, equals 1.20 times 500. All right, and it's 500.0. Include it for sig figs. Okay, now I'm going to do 6.00x equals, and then on my calculator, I'm going to do 500.0 times, and I want you guys to do it too on your TI calculators, times 1.20, and I got 600. I'm going to divide both sides by 6.00 to isolate x. And when I do that, 6 divided by 6 is what? It's 1x, or just x, equals, and then I want you guys to do 600 divided by 6. You guys would get 100.0 milliliters. Okay? So the final answer is 100.0 milliliters. That's your final answer for V1. All right. Problem 3. A student dilutes 25.0 milliliters of 3 molarity of KNO3 to a final concentration of 0.500 molarity. What is the final volume? So let's take a look at this. We know we have a M1 of 3. We're diluting this into something completely else, which we'll get to a little bit later. We know V1 is 25 because we're diluting it. 25, we're beginning with 25, and we're going to dilute it to a final volume. So we're looking for the final volume. So V2 is unknown. And then M2 would be what, you guys? 0.500 is the final one, final concentration. So, oh, I put a decimal point there, sorry. So, I could write a little nicer. Okay, so I'm going to do 75 for V2. Divide both sides by 0.500. And by doing that, well, let's start with the numerator. What's 25 times 3, you guys? 75 divided by 0.500. You're going to get 150 milliliters. I wrote it all in milliliters, so this is your final answer. So just don't forget your units. Be careful not to mix up initial and final values, and make sure you don't convert to moles unnecessarily. And if water is added and concentration changes, use M₁V₁ equals M₂V₂. Dilution problems are predictable once you get the groove of things, and I think that hopefully my video did that for you guys. I thank you guys so much for tuning in and listening in. Please hit that like button, please hit that subscribe button, and STEM is for everybody, especially you. Thanks, guys.